Well, hi and welcome to my shop this morning. It's, what is it, February 18th, and holy smokes, if this radio isn't causing me a lot of headaches. Now, the really good news is I believe I found the correct schematic. It wasn't all that hidden away, just a little more hunting on the internet. So I think I have the correct schematic. At a quick glance, same three bias resistors are on this schematic. It looks largely the same as the schematic I was using. But I have the correct schematic now, so that's going to be very helpful. It has a lot of interesting or helpful data on it, tube resistances, pin resistances, stuff like that. But the bottom line here at this point, what I've got going on in my head is that someone has changed a couple of resistors, a couple of bias resistors, and made mistakes doing it, and have rendered this radio inoperative. Now, what are the chances that that's true? Hey, there is a chance. People get these radios, they do work on them, they maybe shotgun the capacitors or do something of that sort, and in the end the radio doesn't work and they can't figure it out, just like me right now, only they give up. I tend to not give up. They give up, and then the radio eventually winds up on my bench right here. Is that really what's happened here? I don't know. I really don't know what has gone on here, and I don't have any faith that I've put these three capacitors in the correct place. I probably have, but I don't have faith in any of this anymore. I'm just filled with doubt. So what I wanted to do was focus on these three resistors. This one, and what looks for sure to be an original one. These appear to be in series, but they aren't really in series. So let's start really by looking at the new version of the schematic and seeing what's new about that. Okay, so this has come from Pacific TV. You can see it here, Pacific TV, which these guys have collected a lot of Canadian schematics. So it's a very, very good source. So thank you very much to the guys and girls at Pacific TV. I think that's in British Columbia. Okay, so here we go. Right away, let's go to those resistors. Oh my gosh, there they are. Virtually the same values. 270, 30, and 25. And what I come across when I look at this is 290 here in the original old resistor that's here, and then these two are in the hundreds of thousands of ohms. These two. So I see this wire coming off here. I didn't see that in the radio. My impression was this resistor connects at a spare terminal to this resistor. There's nothing coming off that terminal. Got the cathode of the tuning eye returning into here. It just keeps getting a little stranger. Like most of these are bias resistors, and you use them to drive grid biases. So for instance, the cathodes, you can see, I think I explained this before, the cathodes are all right on the chassis. Oh, wait a minute. Yeah, there's a connection right here. And I think the ground symbol's upside down. And that chassis connection comes back to here, and the current flowing in those tubes wants to flow through these resistors. So this is cathode potential. This is more negative, and more negative again. So it's a little bit more negative being sent to this little one grid on the audio tube. That's the same as the other schematic. This one was being sent to the grids at the front of the radio. Did I trace this wrong? Well, I didn't go far enough. I come up here on the plate here. I think that's correct. And then, yeah, grids here. Might seem kind of odd that the grids back here are hooked up plate here, but this is just a rectifier tube. There's no real B plus placed on the and notice too there's a capacitor right here, small capacitor. They're not actually connected the way it looks at a glance. So so this doesn't exist in my radio. I don't have a magic eye, so we can kind of ignore this piece here. Now this resistor was controversial. Is it this one? Maybe not that one. Well, you know, that was the other schematic. I'll just ignore what the notes were on the other schematic. There's the two light bulbs. It all looks really very, very similar. I'm not really spotting any big differences. Everything seems to be in the same place. Here's the volume control here. Interesting how they've shown it. It's just a little easier to look at. So let's run through the radio from start to finish here. So the first tube in the radio is the mixer tube. You can see all the grids in there. You can see grid 1, 2. Hey, what's going on in this tube? So they're doing some strange stuff with the operation of this tube. Strange, I shouldn't say really strange, but in the early days, they really hadn't settled on how to, and this isn't all that early, this radio, by the way. They really hadn't settled fully on how to utilize these tubes. So there's various grids you can put signals on and do things with and get varying results. All of them compromises between benefits and problems. So different engineers might select a different way to operate these tubes. So with that in mind, typically you do oscillator on grid 1, and then you use grid 2 as kind of like a fake plate. Maybe even grid 3 in this case as a fake plate. That causes the oscillator to vary the electron stream coming off the cathode. That variation is carried through right to the plate, and then that varying electron flow is then further influenced by this grid in this radio. This is coming from the antenna. So you end up in this tube with the antenna signal and the signal from the local oscillator here. Okay, if you don't realize it, perhaps you don't, radios convert the frequency on the antenna to one internal frequency and feed that internal frequency through the bulk of the radio. So the tuning part of the radio is usually just the very front, and that is also a signal conversion. So for instance, you want to listen to 640 AM, that's a station in Toronto. You convert it using this tube and the oscillator to a new frequency. You get it away from 680 and get it at, you don't really get it away, you create a new signal, in this case at 456 kilohertz. That's written on here somewhere. There it is right there. Big bold print. 456, not 455. 456. So when those two signals encounter each other in the electron flow inside the tube here, for a couple of different reasons, one being non-linearities of operation, or this other thing I just described, the modulated current flow through the two signals get mixed together, and the interesting result of doing that is you still get the two signals coming out, and you get a couple more. In fact, I think you get a lot more, but you get two primary additional signals coming out. One is at a frequency that's the difference between the two frequencies that are in the tube. So you have your 680 station, you have your local oscillator, which would be just somewhere around 1100. I'm just making that number up quickly. And you mix those guys together, and between them is 450 kilohertz. The rest of the radio is listening to that, listening only to 450 kilohertz. The rest of the radio is right here. So any other frequency stuff on the antenna, this guy can't hear it, because only 455 kilohertz signals will make it through this tube, get boosted, get cleaned up here a little bit more, and then they go to the magic detector. This tube's job is to reveal the audio signal that is somewhat hidden in the radio signal up to this point. Hidden in the sense that you can't take the raw radio signal and somehow deliver it to a speaker and hear something. That's not going to happen. So the interesting thing is, if you chop the signal in half, if you eliminate, let's say, the negative going portion of this alternating current signal, and you just have the positive going portion, it's very easy to recover the audio after that. And that's what's going on down here with these capacitors and stuff. They're trying to recover the audio, throw away the RF, any that's left, and send audio on into this tube. So it's a radio from here past the detector. It's an audio amplifier. So now this is an interesting arrangement. This is actually two detectors here, two sets of plates in this tube. Again, radio engineers do different things at this point. What this engineer of this radio has done is he's using one half the tube to do the audio detection and drive forward out the radio, the audio sound. The other one's being used to produce a DC voltage, a varying DC voltage that will vary with the strength of the incoming signal. This is a really handy thing to do. It happens almost by accident with this tube, but engineers can make use of this accidental voltage. If they do it right, the voltage will be negative relative to the chassis, and they can apply that negative voltage on the grids of especially these front tubes and control their amplification. And this becomes an automatic volume control. Raise and lower the gain of these front tubes in accordance with the strength of the signal. Sort of a self-regulating thing if you think about it. The result of that is the volume coming out the speaker remains essentially the same as you tune through different stations of different strengths, or you are listening to, let's say, short wave, and the signal is fading in and out. This will compensate for the fade. So that's what's going on. All radios, virtually all radios, have this in it. See here it says detector and AVC, automatic volume control. If they didn't have it, you'd have to have your hand on the volume control as you tuned. And also, the amount of amplification required in these tubes to raise a weak signal up to the point where you can hear it is far too much amplification for a strong signal that it should encounter also on the antenna. So you really do need to regulate these tubes if you want to have the radio be able to receive a range of signal strengths. So we're moving along here now. It's just audio here, volume control, and we then have audio amplified by this tube and then applied to this final tube, which can produce some power to drive the speaker. That's basically what's going on in here. I didn't explain too much about these coils. So these coils are related to the antenna and provide the first stage of selection and tuning in the radio. You see the adjustable capacitors here. These are trimmers for adjustment that I need to adjust when I get the radio operating well. And this bigger one is the actual tuning one that you turn. This radio has a 3-section capacitor. Let's see how that works. So here's one section. Now over here we need another tuning section. Oh, I think it's right here. So this is also part of the big capacitor you're operating when you turn the tuning knob. And this is working against these coils and coming up with a local oscillator frequency. This is the band switch here for selecting different sets of coils, depending upon what band you're on. Yeah, 1, 2, 3, not 4, 3. And so tuning here, this is a little unusual. Tuning here and tuning here too. It's a little odd. So, you know, the engineers get really crafty and clever when they're doing these things. And through experimentation, they might find circuits which are not intuitive, but do the job. And you stick them in the radio, and then guys like me look at them and go, well, what are they doing here? They may not even be so sure what they were doing. That's probably not true. They probably knew exactly what they were doing. So, lots of adjustments here that'll have to be made. That's it. Or did I explain these? So the whole idea here, yeah, I did sort of explain them. So this capacitor and these coils work together to produce a local oscillator frequency, which typically is this amount above the target frequency. So if you want to tune to 680, the local oscillator will be running at 680 plus 456. That's about 1100, something like that. Somewhere in that range, 11 something. In an AM band, this the local oscillator is almost certain to be running above the tuned frequency range. Rather, it can run above or below. Either way, you get a difference of 456. But if you run it below, it's very challenging to sweep the oscillator range that's required in a radio. It's very difficult. If you put this above, it's easier to make the local oscillator range range the way it has to. That's why it's typically above. That's also why typically you look at the tuning capacitor in a small radio, you see two sections. One has physically larger plates, one has smaller plates. Smaller plates are almost certainly the local oscillator. Notice I say almost certainly. I like to throw in those weasel words here and there. Socket voltages. This is great. This may help us a lot. Sort out what's going on in this radio. Just looking at the tubes in here just to make sure there isn't something weird. No, they're exactly the same. But socket voltages measured between socket terminals and chassis. Bottom view of chassis. It's just a different radio. What are they doing here? Oh, here we are, up here. 146. Okay, 146. Volume control on full, antenna grounded, range switch set on broadcast, dial tuned to 526. Use high resistance meter, grid bias is that when measured across 29. Yeah, 29. Grid bias for the 6F6 tube is 19 volts. So here's the whole thing that's got me concerned here. 19 volts. You need this string of resistors to produce that voltage. You don't put that voltage on the output tube, it won't be long before the output tube cooks itself. These just seem to be all messed up in this radio. And it's up to me to sort out what has really happened. Well, thank you for thank you for having the correct schematic. Anyway, I have a fighting chance here now. So I think the next thing is we're going to look at those three resistors and everything going on around them and try to figure out, are they what I think they are, or what happened here? And maybe before I go any further, I'm just going to mention the COVID situation here in Orillia and Barrie. Orillia is where I live. Barrie is a large city, just 10 minutes down the road. And the general area that I live in, the province I'm in has 15 million people in it, and it's broken up into regions, medical regions. So we're in a medical region here that's associated with the big city south of us. So some of the statistics that I get from the government cover an area that I'm in, doesn't necessarily cover the town I'm in. The situation is the area I'm in is Canada's hotspot for the UK virus. The current thinking is there may be as many as 500 people with that virus in my area. My area has a population of, it couldn't be over 200,000. It couldn't go over that, I don't think. So 500 people, about 150 have been tested for sure, and the rest, their tests are being done right now, but health authorities are pretty sure it's going to be the UK variant, which means the UK variant is on the loose in my area. Here in Orillia, hard to believe it wouldn't be. People regularly travel between Orillia and Barrie. It's just, Barrie's the big city you go to do the big shopping. And although everybody here, as far as I can see, has been laying low big time, especially my wife and I, we've certainly been laying low. You can't fully hide from this stuff, can you? You can't fully hide from it. So that's a scary thing. A UK variant apparently breaking out right in the area I live in. So every couple of days, maybe I'll I'll make a little statement on my videos there as we go along. But okay, that's good for now. I'm gonna ponder the situation here before I really start going at that radio. So I think what I'm going to start off with is I'm going to take my fantastic sketch here. Here's the first resistor. That's this old one here. I'm going to continue this up through these resistors, figure out what they're attached to, wires running from them, what is going on with those resistors. Then I will try to find out if these up here, these resistors are valid. I don't think they're valid at all. I haven't seen this size resistor anywhere in this radio schematic yet, but I haven't looked that close. So that's what I'll do. Map out the stuff. Okay, so how easy is it to get fooled in these radios? So right at the bottom of the screen, you can see the very top of the resistor that I'm trying to trace. That's down right, let me get this on camera here, down here. You see the black lead come up and go to this terminal, this one right here. Then you can see a black lead disappearing. It's going to that other resistor. You can see over here. Now, I put megawatt light on this. That's what I'm using to see. Now, with what you're using to see, do you think there's more wires coming off that terminal than the two I pointed to? You see the green wire coming up and going into a black sleeve and then carrying on. Not really. It doesn't go in the sleeve. The sleeve is on a wire which is connected right on the corner here. I'm having some trouble moving my stick. Right there. Hidden from view for sure. By eyeball, boy, the chance of spotting this is so small. With bad lighting, it's all hidden under these wires. So, okay, so I'm just showing you how easy it is to make a mistake. And probably showing you a mistake right now. I'm going to carry on. Now, a little more to show here. Just carrying on from the pin that's center of the screen, following the black thing up. Oh, it turns into a yellow thing, a yellow wire, and then back into a black thing, cover, and then it goes up to this terminal, and then we follow it away to the left. We see another similar wire with black things and the wire exposed in the middle. So those two things, that there and that one down here, those are resistors. Those are the resistors I've been looking for. But they're not in the form of a classic resistor. They're in the form of a piece of resistance wire. So the bias resistors are in here. It still raises the question as to what that green thing is doing there and the other green one down here is actually doing. I'm probably going to find out they're perfectly fine. That's probably what's going to happen. I'm probably going to find out this thing is wired correctly, and that all of my crazy machinations have just been that. Okay, so we're going to carry on now, tracing these resistor wires and seeing if this adds up to the correct circuit. The difficulty here is you see all the pins on that tube? Well, some of those pins aren't used for anything except the radio engineer has used them as terminals to make connections on. And this makes tracing circuits and radios very tricky because you think, oh, that's going to that tube. But it's really not. It's just going to a spare pin on that socket. So very, very confusing stuff. That's my excuse. That's my excuse for making so many mistakes when I do this stuff. Yeah, a lot of mistakes. Okay, back to tracing here. Okay, let's play around with some English just for a moment. So I've made a mistake. A mistake. My take on this radio is wrong. I missed with my take on this radio. It was a mistake. A mistake. A mistake. A mistake. A mistake is when you think something is the way it is and it really isn't, and your take on it was wrong. That's a mistake. Hey, thought you'd enjoy that. Okay, so I'm going to try to measure each of those series bias resistors and compare them to the schematic I have here. So the first one is resistor number 27, should be 270, and I think I measured it previously at 290. Of course, these measurements are being made with the resistor in circuit. Well, that's quite different from what I thought I measured earlier. 322 and it should be 290. And the color band, first color is red, and the resistor's in rough shape. That for sure has got to be changed. Okay, now the next ones are quite a bit smaller, which is probably why they use the wire technique, the wire resistor technique. And the next one should be 30 ohms. Again, I'm measuring it in the circuit. But what else can I do? See something like 30? That looked more like a 0, didn't it? Let's try it again here. Hard to believe it would be 0. Huh. Okay, let's measure the third resistor. Again, it's supposed to be quite low. 25 ohms. This one goes to ground. 0 again. Oddly enough, I saw 25 there for a fraction of a second. What's happening here? Is my meter gone bonkers? I don't think so. Quickly, somebody give me a resistor to measure. Here's one. Good, 100 ohms. This meter is becoming unreliable. That's better. Yeah, the switch is becoming unreliable on it. Interesting, it would go to 0, but not go open. I should have noticed it wasn't going open, sir. Let's just check this resistor now. It's supposed to be 100 ohms, reads 98. That's good. Okay, now we're back in business. We'll start with that first one again. Okay, now we're reading 41 ohms. Okay, and the second or last one, 37 ohms. 41 and 37. (41 and 37 together would be 78. I'm gonna write those numbers down. Oh, so one of them is supposed to be 30. That's the middle one. Let me check the middle one again, because maybe it's right on the money. So if that's supposed to be 30, it's coming up 40. Yikes. 30 coming up 40. Coming up 40. And the next one is supposed to be 25. And it's coming up almost the same, isn't it? 37. And then the initial one is coming up at 300 something. I didn't write the number down. $322. $322. There's a chance that these resistors have drifted high in such a way that they maintain the same voltage division in the voltage divider they've set up here. So, you know, like 30 is 40, 25 is 37, 270 is 322. It really sounds like the same ratio, it's just up a bit. That's going to cause like having higher resistance here. You would think the B plot or the bias voltage at this point would be disastrously high. Well, it can't be disastrously high in the sense that there's no disaster. What would happen is a very quiet radio. We have to measure the operating voltages here, here, and here at this point. If they turn out to be relatively correct, and exactly what that is, I guess I'd have to calculate it. I don't know what it is. It doesn't say here. It doesn't say really. I thought it said, oh, it says in the write-up it talks about it. That's right. In the write-up it gives you the voltages down here. So I'm going to look for those voltages in the radio. And you know, maybe everything's fine. Okay, so now part of the mystery is no longer a mystery. So what about these nice, shiny, green capacitor here, which is a little overlit for you. That looks so new and all that kind of stuff. There's one here, there's another one down there. I thought they were the series bias resistors. They are not. They are two 500,000 ohm resistors sitting here and here, just as they're supposed to be. Again, nothing wrong here. It's the puzzle in my head that I'm having trouble with. Okay, I'm going to use the indicating meter to make these measurements. Ground is on, probe is ready. And we're going to run this through the dim bulb again. Just 100 volts from the source through the bulb to the radio. Here we go. Ooh. We're reading fairly low voltages here, negative voltages. I'll put it on a 50 volt scale to start off with. First one we should see is 19 volts at the ground point of the capacitor there. So 50 volt scale, 19 brings you up around here. That's where this should go. So we've got, now this is low voltage supply, so let's jack this up. I'm only at 72 volts. Let's take it up where it needs to be, at least 110 or so. Well, I may have some trouble getting there this way. These bulbs are dropping too much. This thing's pulling a fair bit. 86, 91. Yeah, you know. So what I'm gonna do is I'm gonna cut the bulbs out of the circuit here. So we're around 100 volts now. 90. Let's just check the current here. That's more than before, but nothing to write home about. We're at 107 volts here, a little higher. 110, 111. Okay, so we're in the range now. What do we get on here? So now we're seeing on the 50 volt scale 25 volts. Well, it should be 19. Oops, bad. I slipped. And in fact, this radio could be powered at an even higher voltage. If you plug it in an outlet here, this guy, he could easily get up around here. So now we're at 27, minus 27. Well, the benefit of that is the higher negative bias reduces the current flow through the tube and unloads unloads the radio a little bit, unloads the power transformer a little bit, unloads the tube mainly. But you crank it up, get a loud volume out of the radio, there's a chance you'll drive the tube into inappropriate operating conditions because the bias isn't centered properly. At 19, it's gone high. So that's not the end of the world. That's actually, if it was the other way around, I'd be a little more concerned that we'd have to do something. We don't have to do something for the sake of the output tube. Now the next one up on the chart here, it says grid bias for the 6A8 and the 6K7, the two front tubes. On this wire right here. Yeah, coming over here. You don't actually try to read the grid voltage because you get on the far side of these big resistors, and this is a high impedance circuit here, and even my good meter is going to load it a bit, so you get a false reading. So they're going to have you do it back here and then make an assumption. If this voltage is right, this voltage is right. That's what they're driving at here. The grid bias for the no, not that one, this one. The grid bias for the 6A8, 6K7, and the anode voltages of the AVC section of the 6H6 is minus 3.5 volts, measured across resistors 29 and 54. Can we do that? 29, and yes, we can, because I have the meter hooked up on the chassis. We just go past the first, it's basically past the first resistor in the string, and we get the reading. And what was this supposed to be? Minus 3.5. Okay, I'm going to put this on the 15 scale, because I think it's going to be correct. So we just have to hit it here. So now 15 scale, that's 5 volts. It's supposed to be minus 3. Minus 3.5, and we have 5 volts, but I'm hitting the radio with 118. 118 volts is typical. So this is what the radio would probably operate at. Minus 3.5, minus 5. Well, that's almost a doubling, you know. We'd have to really look at the tube charts and everything. Okay, let's do the last one. The last one. Grid bias for the 6F6 is minus 1.5 volts measured across resistor 29. Okay, resistor 29. Let's just go to the next spot. Something's smelling a little hot in here. Can you smell it? No, you can't get smells through a video. Oh, you know what? I think it's just me. It's definitely something is hot. It's coming up through here, or it's coming up. You know, it's maybe just this row of hot tubes here, just producing heat. Okay, I'll just keep a nose on that. Here we go. And what are we looking for? Was it minus 1.5? And in this case, 15 scale, 2.5 instead of 1.5. Could these biases be responsible for the radio not operating? No, quite the opposite. The radio's working. Seems to be. Okay, radio's working. What did I do to make it work since yesterday? I haven't done a thing except look at it and talk about it. Measure it. Tone control works. Something is definitely getting hot though, so let's tune around here. By the sounds of it, I am on the broadcast band. We got to hook up an antenna. I'm getting excited now, right? Because now I know I'm home free. Home free from here. Yeah, we'll just hook up the lead wire here. Now the radio's gone quiet, maybe because it's generating such a high AVC bias, it's quieted itself right down. So it's full volume. Let's see what we can get now. We're at 6, we're right near a station. I can feel my whole bench vibrating. The speaker's producing the bass, all right. How do you like that? It doesn't say magic guy, it says magic dial. Magic dial. What do you mean by that? Anyway, here we are. Look at that. Thumbs up on that. I have no idea how I got there, but I did. Yeah. Well, I should have just turned the stupid thing on this morning. It's not stupid. I'm stupid. Okay, great though. I mean, I'm learning more about the radio. I'm getting better at understanding how it operates and getting more likely to do a good job doing the alignment on it. And I'm more likely to find more problems should things not work out. I get a better understanding of the radio. So all that running around, maybe it was all for nothing, kind of. But you know, that's, as I say many times, we pay a price for education. You're paying the price for my education. And to be more specific, I'm just learning about the specifics of this radio, you know. It takes time. Good news though, radio's working. So now I can focus on getting rid of all these other tired old capacitors. Excellent.